And this is session 3, which is our last lecture for Module 1. And Module 1 really was hopefully a review of stuff you've learned before. These lectures are pretty quick and concise, so there's a lot more information in your readings and in the additional resources listed in Blackboard. So really I'm hoping these are just an overview kind of lectures. So we talked about the 3 big ways of describing data: graphing, talking about the central tendency, and talking about the dispersion. So in session 2, I talked about different ways to graph data to visually display it. In this lecture, we're going to talk about central tendency and dispersion. And these are ways to summarize data with numbers instead of graphs. So it's just another way that we can communicate about raw data. So first we'll talk about central tendencies. So central tendencies give you what a typical value in a data set would be. So if you have a whole big data set and you want to know just what's a typical value, you don't want a picture, you don't want a chart or a graph, you just want to know what's kind of an average typical value. And so there's 3 ways that you can determine this one number that would represent the data set. And these are mean, median, and mode. So mean is the average. So we can only compute this for interval or ratio level data. So that should make sense. Let's think if you had a nominal level data, let's say men and women. Can you calculate the mean or the average of 32 men and 41 women? You can't add all the men together and add all the women and divide by. It doesn't work with categories. So that's something to think about, is that when you're talking about mean, you should always have interval or ratio level data. And sometimes, often you'll see in the literature that there's mistakes around this, and that's the time that your ears would kind of perk up when you're reading an article, is if it said, let's say it said the mean education level for the sample was some college. Well, that tells me that you probably collected the data as maybe high school, some college, bachelor's. You collected categorical data, and so you really can't take an average of that. If you calculated number of years of college, you could take an average of that, but you can't, your average of something can't be some college. So you'll see that hopefully now that you've thought about this, you might see in articles where someone gives you the mean or the average score of some sort of categorical data. But so all a mean is you add up all your scores and divide by the total number of scores. So if this first line was our data set, if we got a 1, a 3, a 4, a 6, and a 7, all we would do is add those all up and divide by 5, and we would get 4.2. So that's the mean of this data set. So the next type of central tendency is median, and this medians can be calculated with ordinal, interval, or ratio level data. So all a median is it's your middle score. So it's the score at which half of the data is smaller than it and half of the data is larger than it. So all you need to do is take your raw data and put it in order. So it can go smallest to largest or largest to smallest. It doesn't matter. But this is why you can't do this with nominal level data. So with categorical data that there's no order to, you wouldn't do this. But like for example, let's say you were collecting race. There's not really a way to order race. So you couldn't calculate the median of race. But if you had any kind of ordinal or interval ratio level data, you would just list out your data in order, and then you would find the middle point. So for the top data set, there's an odd number of values, and so it's really easy to figure out our middle. It would be the number 4, because there are 2 values below 4 and 2 above 4. For the bottom data set, you can see there's an even number, so there's not a middle value. So what we would do with an even number is we would find the 2 middle scores. So it looks like 4 and 6 are our 2 middle scores, and we would average them. So you would add them together and divide by 2. So 4 plus 6 is 10, divided by 2 is 5. So the median of the second data set would be 5. And the last type of central tendency that we'll hear about is the mode. And this we can actually calculate with any type of data. So with the nominal, ordinal, interval, or ratio level data, you can report a mode. And all a mode is the most frequently occurring value. So in this data set, you can see 7 is our mode. It's our most common value. You can have more than one mode. So if we had a data set with 2 1s and 2 7s, we would say there are 2 modes, 1 and 7. So it makes sense. You can do this even with nominal data. If you had listed out that you had 53 men and 13 women, you would say men, the majority of the data was men. So that mode would be men. And finally, we talked about graphing, central tendencies, and then lastly, we're going to talk about dispersion. So measures of dispersion, what they tell us is how closely the values cluster around that mean, median, or mode. So remember, central tendency gave us a point value. It gives us one number that represents your whole data set. So that doesn't give you the whole picture. So how spread out are the data around that one central tendency? Do the data cluster really close to it, or is there a lot of variability among the data set? So that's why oftentimes you'll see a median reported and then a standard deviation. So that tells you what's kind of an average score and then how much variation is there around that average score. So let's see, variance and standard deviation, those are really common ones you'll see with interval or ratio level data. And in your book, it'll talk to you about how to calculate the standard deviation. It's not something that you need to be able to do. What I want you to be able to do is to look at a standard deviation and ask and figure out what it's telling you. So if you have an article that tells you the standard deviation of something and it's really small, that tells you that the data points all cluster close together and they're close to the mean or the median. And then if you have a standard deviation that's really large, that tells you the data are much more variable and there's a lot more variation in the data. Variance and standard deviation are related. The square root of the variance is standard deviation, so they're just kind of a mathematical manipulation of each other. A range is a very simple measure of dispersion, and all you do to calculate a range is you take the maximum value in the data set, subtract the minimum value, and that number is the range. So the bigger number, again, that you have for a range means there's more variability in the data. The smaller number you have for a range means it's more clustered and the data is closely related and less variable. And then lastly is the interquartile range. So remember this from when we looked at graphs and we looked at the box plot or the box and whisker plot. Interquartile range will give you the 25th percentile, 50th percentile. So remember, the 50th percentile is the median. So the interquartile range gives you around the median, the 25th percent and the 75th percent of the data. So picture your box plot, and which is kind of a visual depiction of the interquartile range. And that is the last lecture for Module 1. So make sure you do your readings, and any of these concepts in the readings or that we briefly reviewed in the lectures that are confusing or that you don't remember from previous classes, please go to Blackboard where I've listed some additional resources and explore these and really feel comfortable with them before you complete assignments.